All right, hello everyone. Welcome to our session of Navigating Biases in Accessibility and Aging. My name is Lawrence Kim. I'm an assistant prof at Simon Fraser University in Canada. And we have amazing 7 talks today, including an honorable mention. So I'm really looking forward to seeing all the presentations today. I do want to mention that we have a town hall scheduled right after this session, so we'll be really on time in terms of the presentations and Q&A, and so we might limit the questions to 1, at max 2 questions. So with that, we'll start with the first presentation by Bran Knowles from Lancaster University on cohort differences in internet use among older adults. So I'll let her take it away.
Okay, thank you very much. Let's do this thing. Okay. So decades of research on HCI and aging tells us that age matters to technology use. But at what age do we start to see important differences in users? Does age 65 plus still work as a definition for older adults in our field? This paper builds on a previous paper that we wrote called Not Just a Number, which typologized multiple dimensions of aging that are explored in HCI. And here we wanted to see which of these dimensions seem to matter most to internet use in later life. So the wider context for this paper is trying to understand what underlies the persistent age-based digital divide. Is this an access issue, a skills issue, or is this to do with the perceived value of digital tools? And answering that matters to how we might address this problem, or indeed whether it should be thought of as a problem in the first place. So we had 3 research questions for our study. The first is, how do internet use and reasons for not using it more differ between age cohorts? The second is, which factors, if any, are associated with the age gradient in not using the internet? So our health, lifestyle, or sociodemographic factors. And the third is, what reasons do older adults give for not using the internet more? Was it motivation, skills, or access or accessibility issues? So we analyzed wave 10 of the English Longitudinal Study of Aging, or ELSA, and this is a nationally representative survey of men and women aged 50 plus living in the community in England, with data collected approximately every 2 years since 2002. Our study included more than 6,000 participants, and to see if there was an important difference between those older and younger than 65, we divided participants into 3 groups: 50 to 64, 65 to 79, and then an old group of 80 plus. And we performed logistic regressions on the data, the first looking at odds of internet use across these 3 age categories, the second testing various demographic, social, mobility, and health factors that have been theorized as possibly accounting for the age gradient in internet use, and third, analyzing reasons respondents gave when they were asked why they did not use the internet more. And we assessed these together with specific age-related factors, things like poor vision and health problems. So our analyses confirmed an age gradient in internet use. That use drops off as age increases, but not steadily. So the age gradient steepens dramatically, not within the 65 to 79 category, but in the 80 plus category. That said, we found that a sizable proportion of people in their 80s and 90s are digitally active, if less frequent users. In our analyses, we divide respondents into 2 groups. We have the rare users, those who said that they never or seldom use the internet. That's the blue on this figure. And regular users, those who said that they used it daily or monthly or more. And that's in the red. And when we looked at the reasons that rare users of the internet gave for not using it more, none of the reasons were endorsed with greater frequency in the 65 to 79 or 80 plus groups compared with the younger groups. And actually, lack of trust is mentioned much more frequently in the youngest group, about twice as much. The ELSA includes data on a number of health, lifestyle, and sociodemographic factors. It's actually not primarily a survey of internet use at all. So this meant that we were able to test correlations with a number of factors, including sex, rather than gender, because this is what the ELSA survey asked. Wealth, education, employment status, marital status, mobility impairment, health conditions, and cognition. We also tested more specific factors on the right-hand side, including dexterity problems, arm mobility problems, poor hearing, poor sight, depression, loneliness, and self-rated cognitive ability. And only 3 factors appear to have strong explanatory value for the age-based digital divide, those being poor cognitive ability, less education, and not being in paid employment. And together, these 3 accounted for 16.3% of the age gradient in internet use. These other factors were related to internet use, but they did not appear to account for age differences. So in other words, they were not endorsed to a greater extent as age increased and use decreased. Finally, we looked at differences between our age categories in terms of the reasons respondents gave for not using the internet more. And in the survey, they were given these options in the table on the left. These weren't written by us. The most commonly endorsed reason overall was not having a reason to use it more. The least common reason was vision or health problems. Overall, factors such as lack of skills, lack of trust, and poor connectivity did not explain the age gradient. However, we did find that the reasons for not using the internet more differed in significant ways between the rare users and the regular users within any age category. So for regular users, the factors associated with the age gradient in amount of time online include, in order, poor IT skills, not having good reasons to use the internet more, and lack of trust. And here we see lack of trust increasing with age amongst regular users, which is the reverse of what we saw with the rare users. So the lesson here is that when seeking to understand the reasons older people are not using the internet more, it's important to distinguish between whether or not people are digitally active at all and the frequency of use for those who are active. Okay, so our analyses suggest, first of all, that nothing particularly dramatic happens at age 65 in terms of rates of internet use or reasons for not using it more, and actually differences become more pronounced closer to age 80. Now, we can't say exactly what age these differences precipitate, but this suggests the need for more critical engagement with the implications of using particular age groups in HCI, and also the utility of cohort segmentation. So 65 isn't so old anymore, it seems. And maybe the research we're doing with participants within the 65 to 79-year-old range are missing out some of what matters about age and aging to HCI. Our analyses also provide empirical support for the various critiques of HCI and aging research for approaching aging through a deficit model. Our findings refute the intuitive and long-standing claim that functional decline is the primary driver of the digital divide. In fact, physical impairments were found to pose a more significant barrier to internet use for people in the 50s to 64 age category than the older individuals. Overall, the importance of education and work status to internet use supports thinking of aging more as a social process and for engaging critically with life course. And thirdly, while we did not find evidence of access or accessibility barriers to use amongst our participants, we did find evidence of a skills barrier to use, at least for the infrequent or non-users, which suggests that provision of skills support could help mitigate the age-based digital divide, more so than provision of devices or broadband or addressing accessibility. But most of all, we found that older people were generally content with the amount they used the internet. The so-called digital divide seems to represent a choice more than structural barriers. And this underscores the need for discourses on the age-based digital divide to recognize the role of agency in decisions to disengage from technologies in later life, and to consider how HCI can help accommodate agentic non-use. So I just wanted to thank my colleagues here. These are all of the people that I worked with on this grant called DigiAge, which is now finished, but for more information on the grant, I put the website here, and I'm happy to answer any questions.
So thank you for the talk. If you have any questions, you can raise your hand, and there's a question on the back.
Thank you. Hi, Bran. I enjoyed that talk, but you must get this question all the time. It's a cross-sectional survey, so the cohort effect of maybe those oldest people just never used the internet, and it's not actually a drop-off. Could you just say something about that?
I would say that the next step for us is doing more longitudinal studies to sort of answer that. And actually one of the things that I would find particularly interesting is looking at, of those three factors that we found to be really consequential to internet use, looking at when they sort of happen to the individual and then watching the rate of decline in internet use from that point forward. So maybe that's the next paper we write, Kai, next year.
Any other questions? Okay, then let's give another round of applause for the Bran. So for our next speaker, we have Claire Mitchell from University of Washington, and she'll be presenting on ability heuristics for conducting accessibility inspections.
All right, hello, I'm Claire Mitchell from the University of Washington, and on behalf of my co-authors, Junhan Kong, Jesse Martinez, Shaun Kane, Amy Ko, Alexis Hiniker, and Jacob Wobbrock, I am presenting our work, Ability Heuristics for Conducting Accessibility Inspections. So, usability evaluations pioneered a way to concretely evaluate an interface. These evaluations come in many forms, but of note, and what I aim to focus on today, is heuristic evaluation, pioneered through Nielsen's 10 usability heuristics. On the other hand, to evaluate the accessibility of interfaces, the tools most easily available are checklists that are numerous, specific, and often require expertise to use. For example, here I have images showing the web content accessibility guidelines and the game accessibility guidelines, both which have numerous items. So without a concise set of accessibility guidelines, designers and developers, especially those without accessibility experience, are left with few tools to evaluate the accessibility of the interfaces that they create. So to fill this gap in accessibility evaluations, we aim to create a set of accessibility guidelines akin to usability heuristics so that designers and developers would be working with a similar and familiar methodology. We based our heuristics in ability-based design, and to create our heuristics, our methodology was as follows. Over 2 years, we explored with designers how to create these heuristics. In addition, we conducted brainstorming and design sessions. And to achieve our final set of heuristics, we performed a content analysis of the ideas we had generated over the years. We coalesced our ideas into a set of 9 heuristics we call ability heuristics. I have them listed here on the slide, and I'll go into further detail throughout the presentation. But we've organized the 9 heuristics into a structure. The first 6 heuristics are arranged to start from broad themes of accessibility that persist across the entirety of the interactive experience. And these progress to narrow themes that touch upon specific aspects. The final 3 heuristics cover social aspects of the interwoven nature of ability, accessibility, and technology. We validated our heuristics in a between subjects classroom study with 37 designers. Each designer was assigned one of 3 assessment techniques to find accessibility issues. First, we used our ability heuristics. Second, Nielsen's usability heuristics. And third, the web content accessibility guidelines. To ensure an accurate and fair comparison across the different methodologies, we asked the designers to only use the usability heuristics to find accessibility issues as opposed to usability issues, so that we could identify if the usability heuristics could already find accessibility issues sufficiently. Secondly, we asked the designers to use the web content accessibility subcategories as opposed to every single checklist item to ensure an equal burden task between the 3 assessment techniques. We asked the designers to evaluate 3 pieces of technology. The first, Amazon.com on a laptop or desktop device. Second, Google Maps app on a mobile device. And last, PowerPoint on a desktop or laptop. For each heuristic, I'm going to lightly detail its purpose and provide an example issue that the designers found. In our paper, we detail more fully the complete definition and use of each heuristic. So our first heuristic is adaptability, wherein systems should be adaptable to a user's dynamic and situated abilities. One example issue is that on Google Maps, walk time is not adjustable to a user's abilities, especially as these abilities fluctuate. Next is the heuristic equitable experience. Systems should provide an equitable experience for users of all abilities. One designer identified that not all of the images for a product listing on Amazon have alt text. This results in an inequitable experience for screen reader users as they do not have access to the same information as other users. The third heuristic, flexible task completion, emphasizes that tasks should have multiple pathways for achieving them and be easily paused and resumed. One designer noted that routes cannot be easily saved or paused and resumed, putting additional burden on users, such as those with fine motor disabilities, where route creation on a mobile device may be difficult. The fourth heuristic is efficiency and effectiveness of user action, meaning actions should be effective and efficient in bringing about the intended result. An example issue is that users have to take multiple steps to animate multiple items in a similar manner across slides while using PowerPoint. There is no bulk animation tool. This increases cognitive burden on the user. The fifth heuristic is multiple modalities. Information should be communicated via more than one modality and tailored to each modality. For example, for Google Maps, exploration of layouts, intersections, and street views is primarily through a visual modality. Our sixth heuristic is understandable messages, meaning messages should be conveyed in user-centered language. One designer pointed out the issue of Rufus on the Amazon webpage, and that it lacks clear context as to the purpose it serves as an AI shopping assistant. Want us to click on it and navigate to another page in order to gain that additional information. The seventh heuristic, ease of adoption, emphasizes that systems should use easily available components that are compatible with assistive technologies. For example, PowerPoint subtitle services are only available on their paid versions, prohibiting all users from accessing a vital accessibility service. Our eighth heuristic, ability data transparency, details that systems should be transparent regarding the data they capture and store about a user's abilities. One designer noted with Amazon that while you can view your browsing history, you cannot view what ability data is profiled and how your ability data might be inferred through your browsing patterns. Lastly, our last heuristic, help, support, and community, emphasizes that systems should provide accessible help, support, as well as a place for community feedback. After using immersive view on Google Maps, one designer noted that the promoted survey regarding their experience did not include any accessibility questions. While I've just provided an overview of the heuristics and examples of how they can be used, I now want to explain how the ability heuristics performed. Were they able to surface different or more accessibility issues compared to the usability heuristics and the web content accessibility guidelines? So for each issue that the designers surface, they indicated the severity of the issue they identified. So ability heuristics and the web content accessibility guidelines, most common issue severity was a major accessibility problem, followed by minor. Whereas for usability heuristics, the most common issue severity was minor, followed by major. To understand the performance, we evaluated the assignments using inductive thematic analysis, noting both the issues the students found as well as the rationale of choice for each heuristic. From our analysis, one theme we observed, and that I want to focus on today, was the area of accessibility quality. For example, I want to highlight two sub-themes within this area: inequitable experience, and incomplete or inaccurate accessibility feature. For the first, ability heuristics highlight equitability of experiences much more often than the usability heuristics or the web content accessibility guidelines. Secondly, ability heuristics highlighted that the quality of an accessibility feature matters, not just the presence or absence of a feature, with much higher frequency than the usability heuristics and slightly more than the web content accessibility guidelines. So we have many more results about how the heuristics performed in our paper, so please check it out. Thank you.
Thank you, Claire, for the presentation. Now we'll take questions. Yes.
Hi, Claire. This is Ed Cutrell at Microsoft Research. This is really cool, and I like it a lot. One of the questions I have, though, is that WCAG is notoriously difficult to navigate and difficult to do. And I'm wondering, in your experience feels like one of the benefits of these heuristics is that it's easier to understand and maybe easier to navigate. And I'm wondering if you could talk a little bit about the experience of the teams as they were using the different systems as they were doing these evaluations.
Yeah, I think one thing that we noticed, and I don't have here, but I have in the presentation, is that it seemed that the ability heuristics were used a little bit more evenly than perhaps the web content accessibility guidelines. And I think part of that could be because there's more of them. Yet again, we didn't use every single one of them. There's 13 overall subcategories that we had. But even, I wonder if because the performance was a little bit different, if having 13 would maybe be too many.
Great. Thank you for the question, and thank you for the presentation. Let's give another round of applause for Claire. Next, we have a presentation that won the Honorable Mention Award. It's by Amanda Lazar from University of Maryland. The talk is on integrating the us versus them dichotomy in technology research with older results. So before we begin, I'll give the award first. So congratulations.
Thank you so much, and I'm delighted to present on behalf of my co-authors, Elissa, Carpio, Ruipu, Beth Barnett, Kibron, Tesfatsion, and Sheena. So I've been so fortunate to collaborate for several years with Beth, who takes part in a program for residents of our state, age 60 years and older, offering the opportunity to take university courses at significantly reduced fees. A few years ago, she came to me with a proposal that she document her experiences with technology issues as part of an independent study that she takes with me. She wrote in the proposal what I have to offer the research of our group to do an autoethnography where she document her observations and interviews in a way that could be used as research data She offered to gather data about herself, her husband, and others in her personal circle. I was very excited to take her up on this, especially after she sent me her first entry, detailing her issues trying to use a rideshare service. She wrote about how she had to go through many lengths to get support for what should have been a simple issue, including trying to get support from the tech company. As she wrote in all caps in her entry, there is no way to get phone support. She then went on in detail about the granular aspects of the issue, including having 2 accounts, only having a password for one of the accounts, finding a number to call Uber only for it to be a number for drivers only, and so on, until she figured out the workaround herself. I anticipated that this project could let us get a first-hand account of the tech issues some older people face, where a contribution of the project could be to go beyond stereotypes of older adults as tech illiterate, while also recognizing that there are real issues that older people are experiencing. To our team, we added an autoethnography expert, as well as 2 graduate students studying technology and aging. And Kibron was on the team as well, joining later in the analysis stage, so I have him upper right. It felt strange to have just the person over the age of 60 documenting their experiences, like it would be putting someone under a microscope. So we decided to each document our technology experiences with technology issues as well. I had assumed that for the younger members of the team, our experiences with technology issues would largely be times we helped other older people with their technology issues, which I thought would be equally valuable to document our the way we approach this and our emotions that arise, what the attitudes and assumptions are that we carry into it. We spent 8 months as a team writing individual entries about technology issues and then meeting as a team to discuss them. Our entries were regular documentation of our encounters with technology issues, including the moments when things broke, when we helped others, and when we needed help ourselves. Then we met every 2 weeks to discuss our experiences together. We analyzed our entries and our recordings of our meetings, the transcripts of them, following a reflexive thematic analysis approach. In looking back at our accounts, we found technology issues were quite pervasive, helping older adults with their remotes and their microwaves at home, or older participants through volunteer work, doing remote technology support sessions. But something was not quite right about many of our early entries. We tried not to, but we kept focusing in on the older adults we were helping, imagining what they were feeling or thinking as they confronted these technology issues, instead of focusing on ourselves. So one of our team members prescribed us an exercise where we had to document at least one technology issue that we faced. Some of us thought that this was not going to be fruitful. Ends up, it was very fruitful. The team members reflected on how surprised they were. When we first started, like, what kinds of technology issues do I encounter? Then I started really thinking, and I was almost daily. Another team member said, I always assumed I'd never run into technology problems, but in fact, I run into them all the time. The other day, I was setting up the printer, and today I was trying to, just my computer froze for no reason. I'm just trying to restart that. For every category, we found an issue that older adults faced with technology and needed support. The younger members of the group faced issues in that category as well. At work, we had issues with computers freezing, how to work projector screens, and printers were extremely problematic for us. At home, we had issues with our smart light bulbs and our headphones, and on the go, features in newer cars, like those screens, not even that new anymore, and even newer gas tanks caused chaos and distress. Once we became aware of the issues, we also became aware of the emotions that were surrounding them for us. It was frustrating, anxiety-inducing, embarrassing, and even shameful to face technology issues. Frustrating when we were trying to find a Google Doc and we couldn't see the full file name until we finally figured out how to press the keyboard shortcut to zoom out. Other issues brought up anxiety, embarrassment, and shame, especially in public or professional settings. And for us, as researchers and professionals in technology-related fields, there was an added layer where we felt like we really should be able to figure this out, like having an advanced computer science degree and not being able to figure out basic technologies. I'm supposed to be a tech person and I can't print at a printer. Or being in one's 20s, but in a tech field, and negative feelings about how trends were cycling too fast to keep up. Feeling old in terms of relevance of what's in is something that I, one person wrote, feel much more increasingly with regards to technology. Digging into these uncomfortable feelings led us to realize some truths related to our own aging. That technology has been constantly changing, and interfaces like presentation software that once felt familiar could suddenly change. Some of us wrote entries about feeling out of date, incompetent, and dated. We became aware of ways we compared ourselves to what we imagined to be the experiences of younger generations who seemed more fluent with newer technologies. This was happening even with the members of our team that were still in their 20s, imagining 5-year-olds with iPads doing AI. This led us to realize that being part of the tech-savvy in-group is not a fixed state. It's temporary, and we will age out of it if we have not already. If even people in their 20s are seeing changes in technology use as time accumulates, it starts to feel nonsensical to say aging just as a metaphor for older people. Ends up, something that should have been obvious all along, we are all part of this aging category. We are all aging. And there are so many places that we can challenge these dichotomies that try to mark these strict differences between us, the younger people, and them, the older people that we study. The dichotomies that lead us to forget the fact that we are all aging. Challenging the us versus them narrative can happen in many domains, inside and outside of work. Every time we notice a deeper wrinkle or a new gray hair, we can do internal work towards celebrating or at least accepting the positive effects of aging. We can reflect in social situations, like when someone makes a kind of negative joke about aging. What are the feelings that that joke comes from or leads to? And when we write our grants and our papers, can we reframe the parts that set out the issues that older adults have, like loneliness and health problems, to show how these issues actually affect all of us, even if we're choosing to study and support older adults in these problems? A particular shared issue that we may not be confronting in our field is that we all have technology issues. Technologies, interfaces, and paradigms change over time. This means that while we can't claim any kind of equal experiences with technology across ages, the passage of time and relatedly aging does impact the technologies we experience well before we reach the age-based criteria of older adulthood. And we all need technology help. Our team learned that sometimes we need help with our technology issues, and that made us feel vulnerable, something that researchers have also noted as a phenomenon with in older adults, which is another thing we seem to have in common. Over the past decade, researchers have done very important work, showing that older adults are not a uniform group, where seeing groups as uniform is a common effect of othering, and results in design based on assumptions, stereotypes, and simplified models of aging. In this paper, we argue that it may be a fruitful time to look at the us in the us versus them equation, to turn inwards to continue our progress in eroding the divide. Thank you.
Okay, we have some time for questions. So I can start. So you mentioned that technology issues are universal rather than age-specific. So then what kind of concrete design changes should follow? Like how should this reshape current designing for older adults paradigm change in HCI?
Yes, thank you for your question. So I can't claim universality of the technology issues, but I can say that we have technology issues across ages, for sure. And I think there are a lot of examples that we can find once we look. For example, interfaces changing is something that older adults talk about a lot in our study and is a really exciting opportunity for our field to address, like how do we provide support when interfaces change and things become unfamiliar. That also happened to be an issue a lot of people on our team realized that we struggled with quite a bit when buttons moved around, right? So there's going to be distinct issues, but there's also shared issues across age groups that we can definitely find and work towards together, potentially.
Great, thank you. We have one more question.
Thanks for your paper. I couldn't agree more, but I am one of the co-authors on the Bran Knowles paper. I just wanted to, an observation I've noticed is how many people are using Gen AI, ChatGPT, for tech problems like this. So if they'll take a photo and then ask. And I wondered in your autoethnography whether you found yourself using it or talked to people who are using it, and whether, that might be something that we could think about in the future as we get older, that we might start to use it in more practical ways to help us with these.
Yes, that is a very interesting observation. It's funny because the oldest member of our team, she almost kind of stopped us at one point and was like, AI is coming out. Everything is different now. Like, we can't write about our technology issues anymore because finding the solutions for her has become so different because she really is a power user of GenAI to solve the technology issues. I think I'm a bit of a laggard. So for me, I was like, we can still publish the paper. It's fine. But yes, it seems like a very, very powerful tool to address this. But then we're always going to face the issues around the edges, right? Like getting to the GenAI tool, and you still have to have your Wi-Fi on somehow and your passwords, and we'll still have a lot of clumsy issues outside of it, I think.
Great, thank you for the questions and thank you for the presentation. Let's
Thank you.
give another round of applause for Amanda. So next we have Kennedy Simone Smith from Carnegie Mellon University. She'll be presenting the talk titled Identifying, Explaining, and Correcting Ableist Language with AI.
Hi everyone, my name is Kennedy Simone Smith from Carnegie Mellon University, and today on behalf of myself and my co-authors, Lydia Chilton and Danielle Bragg, I'm extremely excited to be presenting our work on identifying, explaining, and correcting ableist language with AI. And I thought the best way to introduce this was to actually have us try exactly this task in the title using an example from the paper. So, let's make sure that this moves. Apologize. Thank you. So, onto the example. Imagine that you are writing a story where the blind character Emily is making coffee. Say, as the aroma of freshly brewed coffee fills the room, Emily felt a sense of accomplishment. Her morning ritual, though simple, was a testament to her independence and adaptability. So the question here is, how would we identify the ableism? Here's a quick example of some things that I personally think are ableist about this example. And now we need to understand how we'd explain it, especially for someone who might think that some of these things are more inspirational rather than ableist. One way that we could do this is by actually asking members of the blind community, which is what we did, and some shortened quotes about how they think this is ableist, is that it could be insulting and harmful, it can be demeaning, infantilizing, and also making assumptions about this person's quality of life. So human in-group expertise is central to actually identifying, interpreting, and correcting ableist language, but exclusive reliance on experts or disabled advocates does not scale to the volume and pace of everyday written communication, and also can place an unfair burden on the community. So luckily, prior work has shown that automated tools could function as first-pass systems that reduce both cognitive load and emotional labor for marginalized communities in doing these tasks. So say, for example, if you ask an AI, our AI here says that this language could contribute to inspiration porn, or the idea that someone disabled is achieving something ordinary is extraordinary. And my question here is, can we really trust AI with this type of task? In prior work, lots of research focuses on the bias and ableism in AI tools. And here's 2 papers that really inspired me and how they evaluated ableism in both large language models and also in vision models. In general, I believe that lots of this work focuses on finding ableist content, working with the community to actually evaluate and annotate this, and then creating benchmarks that people can use to try to make their tools less ableist. However, I think that like some key takeaways for my area of work, which is actually using AI to help people reduce their ableism, is that 1, subtle ableism here is oftentimes more salient than things such as like toxicity or hate speech. And also we need more participatory annotation methods to actually teach people how to mitigate this bias in the first place. So my motivational question here is, how do we actually create a replicable framework for bias annotations that also honor the lived experiences of those who are most affected? And also there's lots of prior work actually looking at bias and ableism detection with AI. Here's an example paper in which it explores different ways that people use scores to actually annotate bias content, as well as using community annotations and creating those into scores that we could use to rank them, and also using AI to actually annotate and create scores. And you can see an example in the screenshot here. However, some gaps in this work is that I believe that focusing on scores and toxicity is something that can be overly rigid and could be punitive, potentially promoting reactance rather than curiosity or adaptation. And I also think that there is lots of minimal guidance in these tools. These systems aren't really telling people how they should actually correct this ableism. They're just saying, oh, this exists and here's why. So my motivational question with this is, how can we actually use AI to educate people on their ableist bias in a way that's non-punitive and also suitable for everyday practice? And a way that I try to do this is in this work by identifying, explaining, and correcting ableist language specifically with AI. I think about how we use the structure in our writing often. If you've ever used something like a spell checker or Grammarly, you know that it finds the thing that's grammatically incorrect, explains it, and also gives you a correction. And in a way, I think that this could become something somewhat like a more educational Grammarly, but for ableism. And I try to examine the qualities of these AI annotations compared to human ones with 3 research questions. So first, I want to know, do humans actually even prefer AI annotations or human annotations? What qualities of these 2 annotations make them agreeable or disagreeable to participants, specifically disabled participants? And also, how could we improve these annotations, thus to serve the community more and help people who want to learn more about the bias in their own language? And for sake of time, I'll mainly focus on the first 2 research questions. So in order to investigate this, we did a 2-part study. In the first part, we collected annotations directly from the disability community. We did this by running 7 15-minute online surveys with 110 participants, and the general task was to annotate a short story for ableist content. I'll explain how those annotations were collected later. Also, in part 2, we compared the human and AI annotations. Again, these are annotations from the disability community with the AI ableism annotations. So we did this through 7 25-minute online surveys with 106 participants, and the task was to compare these 2 AI annotations of the same story, given the assumption that they're both AI. And we told them at the end that one was human and the other was AI. So within the study, I mentioned that we did 7 different surveys, and that's because we wanted to represent the different opinions of various subgroups in the disability community, and we chose these 7 subgroups based on prolifics, self-identification options of the disability community. So these were the communities that we investigated. And something important to note is that these stories that we actually used were AI-generated stories based on a prompt from a previous work that I mentioned earlier in the related work that showed that stories like this create lots of ableist content. And while it may seem kind of counterintuitive to investigate AI's annotations of other ableist AI stories, I think there's also lots of benefits for the study. For example, when we're looking at narratives, it's a lot easier to correct things to honor author intent when you have longer form content. And also this allowed us to control the length of the stories for all different 7 disability groups. And we have some more justifications for why this is valid in the paper. really important contribution of the paper and something that influences the ableism annotations and the quality of the stories is that we needed to define what exactly nuanced ableism is here. We particularly propose a updated definition of nuanced ableism based on guidelines from the Center for Disability Journalism, UN guidelines for inclusive language, and also APA guidelines. And so here, when we talk about nuanced ableism, we're talking about subtle, often unconscious forms of discrimination or prejudice against someone with a disability. Unlike overt ableism, which is explicit and direct, nuanced ableism can be harder to recognize, and this can encounter things like ventilation, inspiration porn, benevolent ableism, and all of these things. I have in-depth explanations of each of these terms later in the paper. So, going on to how we actually collected these annotations, I'll go through this fairly quickly. But essentially, we had everyone read the story, and then we asked them, by going through each sentence, does it actually contain ableism? If it does, you go through a three-part structured annotation section where you identify, explain, and correct. If not, you skip it. And we repeat this for each sentence in the story. And then we also have people look at the overall story in general, if there's any just themes that could be ableist, and we follow a similar structured identification, explanation, and correction prompt, and then you end. So ultimately, the human annotation ended up being instances of agreement within this green structured free response, and then the AI annotation used very comparable prompts for this, and there's a lot more explanations about how we did that in the paper. But moving on to the actual qualities of these annotations, do people actually prefer human or AI ableism annotations? Something interesting that we found is that agreement with human and AI annotations was the same. However, when we asked people to choose which one they preferred, they significantly preferred the AI. So in this graph, what we're showing is that when we did a survey looking at the preference for AI, there is statistical significant preference compared to those who liked human annotations or those who are neutral. And so we go through a series of investigations about what was good or agreeable about these annotations and what was bad about these annotations that made people prefer the AI over the human ones. Something notable about the AI annotations is that they're very consistent and had really clear alignment with the different narrative types and also the differences between the explanation and the physical corrections of the story. But the human annotations were also really strong in the fact that they're really culturally attuned and spoke to more lived experiences. And the community found that both these annotations were both educational and engaging. And briefly, things that were disagreeable about it was that there's still an issue with losing context, and we need to find ways to stop overcorrection and suppressing author voice. And so, running out of time due to technical difficulties, but I have some dialogue about how people in the disability community actually value these ableism annotations in writing tasks. Some participants who were against it essentially are saying things like, unless you're a part of this community, you shouldn't really be writing things on behalf of people in this community. While others say that just focusing on annotating language is an easy way out that ignores the actual things that people are going through. And I think it's important how we frame these tools to ensure that they're not just a band-aid, but a way to keep people accountable. But on the bright side, lots of people thought that they taught them different things about what they think is ableist and using words that they couldn't actually explain in their own words. And some people even said that they couldn't find anywhere to improve this but to spread it to every workplace environment. So I just go through some highlights of contributions that I make. Based on these improvements and strengths, I offer some guidelines. I hope that this can be a replicable framework that people can use to adapt to other communities and make more types of bias annotations. And I also contribute the data set of all the nuanced ableism annotations with over 200 annotations from the disability community, and I give the story probes. And that's it. Thank you so much.
Great, thank you so much for the presentation. Due to time, we'll have to skip questions. So we'll have the next speaker prepared. So next we have Jiung Jun Zhang from Carnegie Mellon University. He'll be presenting his paper on the three praxis framework, a thematic review and map of social accessibility research.
All right, so good morning. I could definitely use another cup of coffee. Okay, so this is going to be a doozy. It's heavy on theory, so please bear with me. So today's presentation is going to be about the 3 practice framework. So it's a thematic review and a field-level survey of the entire field of social accessibility. So let's first start by setting some definitions. What is social accessibility? So in 2011, Junhan and Wobbrock defined the term in their 2011 paper, In the Shadow of Misperception. Social accessibility is about how disability is experienced and negotiated in the social context, and encompasses things like stigma, disclosure, care labor, identity management, all the ways that disability becomes a social negotiation, not just a functional one. And so when I started exploring this without really a goal, I'd go from a paper about co-designing smartwatches with communication tools with people who have aphasia, to a paper about childhood cancer survivors, to a paper about neurodivergent masking in online communities. There's a really vast and wide space. And so as I really delved into this, I found myself surveying 11 different HCI venues over a course of 15 years. 2011 is when the Shinohara paper came out. So we touched on 8,700 papers, tons of papers, 605 papers that I ended up reading myself, and 90 ended up being analyzed. And this overall project, the reason why I ended up reading so many of these was to try to answer these 3 questions that you see on the slides. What, how, and why of social accessibility research? In this particular presentation, this paper actually covers the first 2 questions. The third one, there's an assets deadline in a couple days, so hopefully I'll be able to share you with that soon. So in terms of how we got to that, we started with 8,700 papers through keyword matching. Then we selected for 605 papers. Then we curated the 900. Then through constructivist grounded analysis, we got through codes, and eventually we ended up with 6 themes. And in terms of the what of social accessibility, this is about what types of conversations, what kinds of questions are being asked in the field itself. And due to time reasons, I can't go over each and every one, but they ask really deep and interesting questions. So for example, in the critical making practices, it asks, does what we build challenge or reinforce norms? And there are papers on every side of the ideological divide in this particular subfield. And in terms of methodological justice, it also asks whose knowledge counts as valued in research. Perhaps you can think of a couple papers that fit this definition when you've read social accessibility papers. But the real important thing that I want to get to with my limited time with you all is actually the how of accessibility research, or how is social accessibility research done? We found that there are 3 ways of practice that people do in social accessibility research, or 3 types of research, and they are as follows. Building, we call these artifact builders, so people who build applications, toolkits. Maybe they build ways of conducting workshops, so they make a form that people can read off of during the workshops. Relating, people who do deep ethnographic work and go out and interview many people and get really rich ethnographic data. As well as knowing, which is a much smaller group, but asks really critical questions about why and for whom we build. But when I was surveying the field of social accessibility, I found that most work centers on one practice, sort of an understandable consequence of specialization. But there was a lot being left out in terms of these works connecting with each one another. So what could we learn if we connected them? And where's an example where the dots maybe aren't connecting? So Choi et al. In 2023 ran workshops with autistic adults navigating dating profiles. They found participants chose authenticity. So participants said, I want them to understand me as I am, even knowing that it might cost them chances at dating matches. Crawford and Hamidi interviewed disabled, neurodivergent LGBTQIA plus people in relationships. They found that a bunch of participants did the opposite. They hid their disability from their dating bio because for them, disclosure meant not getting any matches on the dating platforms. And so one participant they interviewed, they met their future partner and neither knew that their partner was disabled on their first date because they were hiding it. Then we have another paper from Critica et al. Who names what that hiding is. It's called masking. Many of you are probably familiar with that term. A participant in that study from Critica et al. Says that masking is like a never-ending job interview for a job that I don't even want. So there's a lot of cost to it. So Choi et al. Finds autistic people want to disclose authentically on dating apps, but Crawford and Hamidi shows that disclosing on these platforms means fewer matches, and so people learn to hide. And then Critical et al. Shows that hiding has real costs: exhaustion, identity loss, anxiety, etc. A tool or a solution built on any one of these without the others can hurt someone or be the incorrect solution. So if you build for disclosure, people might get filtered out. If you build for hiding, people might burn out. Designing dating app experiences for disabled individuals deserves a nuanced consideration of all these factors, but as it is, there is often disconnection in the field. And so we're seeing this in many places, and when building doesn't inform or challenge theory, you get generic fixes that ignore disabled experiences, and when theory doesn't provide constructive guidance, critique is really abstract and doesn't go anywhere, and observations lead to new theory, you get really rich ecosystem insights, but it's not really actionable, and finding from all three becomes really difficult to apply and actualize. But what happens when we have these three praxis and we integrate them? Each praxis feeds the others. What do I mean by that? You build a tool, you watch how people build it, you really talk and interact with them, and spending time with the people who use it shows you what to change. You study a community, and you see what you see gives something concrete to build. You challenge an assumption, and it completely reshapes a tool that you're already making. And let me show you some examples of what this looks like from our corpus. So Curtis and Neat, I think Humphrey might be in the audience somewhere. They spent 300 years volunteering, 300 hours, sorry, not 300 years. I don't think you're that old. Hours volunteering at a speech therapy clinic for people with aphasia. They went in to study AAC, the tools people use when speech is difficult. But what they found was when people like Brian, one of the participants, were already communicating successfully through badges, gestures, they were pointing at their phones. Brian didn't need a device to speak for him, so an AAC device is the wrong solution, and they recognized that. So Curtis and Neat ended up building a device which helped actually emotional regulation of breathing exercises for when anxiety would take over whenever they would enter novel situations, because that was actually the blocker for their communication. Ankar et al. Interviewed 24 childhood cancer survivors and their caregivers, and they expected to find children receiving care in that situation. Instead, they found children performing care. Participant 1 from their study was diagnosed with cancer at age 9. And in this quote on the screen, she's describing how she learned to hide her emotions in the hospital, not for herself, but to protect her parents. She decided that she had to be the strong one in the family at 9 years old. The paper names this as care emotional labor, which is a concept borrowed from workplace studies being performed by a child in a hospital bed. So that observation challenged an assumption that care flows from caregiver to the patient, and instead it was happening the other way around. These children were actively managing their family's emotions, and here we see that relating challenges knowing. And for the purposes of time, I can't get into this really fascinating project Baltasagoni et al., which covers all three of the praxis over a long-running project across 5 years, where they start from an epistemological critique about how empathy methods are harmful because it breeds narratives like what people call inspiration porn. Oh wow, that's so inspiring. Not the thing we want. And then they built it into an artifact, and then they deployed it, and they got new epistemological insights. Encourage you to check out the paper for that example. So, how do we understand what we call the reflexive cycle of being able to integrate all three praxis or bits of it together? Well, there's a concept called cross-training. One of my advisors is super into sports, so I had to borrow this analogy. In athletics, you specialize in one sport, but you deliberately cross-train in adjacent skills because it makes your primary sport better. So maybe you as a researcher, you are a builder, or you perform relating work, or you are an epistemologist and you do epistemological work. Our point is, we are better for cross-training across the praxis in our work. And in research, we are specialized athletes, but I think we will be better for cross-training. So this is our takeaway for today. And I ask that you ask these questions to yourself. So if you build artifacts, what might your artifact reveal about the social relationships it enters? What kinds of historic assumptions does your systems encode? How do you know? If you study ecosystems, what design requirements emerge from these relationships, and how can people actually act on them? What theory does it support or challenge? And if you generate critique or epistemology, how does your framework reshape artifacts and care networks? We encourage you to look at the rest of the paper because there's more to the framework, but we want you to consider which praxis you inhabit, maybe you inhabit more than one, and how you can also borrow from aspects from other praxis in your own work to make better social accessibility research for the field and for disabled individuals. Thank you.
Great. Thank you for the very engaging presentation, Jun. Unfortunately, due to time, we'll also have to skip questions. But if you're interested to learn more about the project, please talk to Jun after the session.
Thank you.
So we'll...
Quick plug, I have another paper on this exact topic, which I was presenting on Monday, so please also check that out. Thank you.
Great. Let's thank the speaker again. And next we have Siyu Zhang from University of Bristol, and she'll be presenting her paper on Beyond Accuracy, Auditing Allocative Harms in Facial Gesture Recognition for People with Motor Impairments.
Hello everyone, thank you for here today. My name is Siyu Zhang. I'm from University of Bristol. My co-author is Yelugu, Kirsten Ketter, and Usama Metatala. And I'm so happy to share our work with you. Camera-based facial gesture interface provide an important hands-free access for people with motor impairment. However, most exciting recognition models are trained on data from non-disabled users, so they often assume that users can control their movements in typical ways and clearly feel their own movements. For people with motor impairment, gestures may be much more diverse. Sometimes their gesture input will be rejected by the systems. Previous research suggests that such interaction failures were mostly due to the difference in users' motor ability. But we found that there is another contribution factor is a diversity in users' proprioception. Sometimes it is not easy for them to sense their own movements, especially for people with narrow-related motor impairments. In this way, the user feels they have successfully completed a gesture while the system failed to recognize it. We define this mismatch as a perception gap. Through mixed method research, we reviewed the cause of perception gap in facial gesture input and provided methods and tools for evaluate these gaps. Let's start an user study. To systematically investigate this issue, we recruited 22 participants in total, including 11 motor impaired users as Group A and 11 non-impaired control in Group B. During the experiment, participants performed each gesture by following the gesture clips, then evaluate how well they were able to perform it. Finally, they provided feedback on how they feel about their gestures. Every participant tested 33 gestures, which were collected from previous studies. For recognition, we used the two pipelines, MediaPipe and OpenFace3, which are widely used in facial gesture interface and related researches. We collected the recognition results from the recognizer, self-evaluation score from the participant, gesture tricks of their movements, and their feedback about their feeling of gesture. Let's start with the quantitative results. On MediaPipe, the motor impaired group achieved an average accuracy of 56%, compared with the 74% for the control group. The same pattern also appeared on open face, where the motor impaired group also showed significant lower accuracy. The heat map gave us a more detailed view of the results. Warm colors represent the low accuracy, while the cool color represent higher accuracy. As we can see, the motor impaired group contains noticeably more red grids than the control group. That indicates lower overall recognition accuracy. In contrast, if we look at the self-evaluation score, the difference between these two groups is much smaller. Most participants in both groups believe they had successfully completed most of the gestures. The real problem appears when users believe they did the gesture correctly, but the system doesn't acknowledge it. To quantify this mismatch, we introduced a new concept called perception gap. Perception gap is defined as normalized self-evaluation minus the model recognition outcome. When perception gap is positive, which is showing in red in this figure, it means the user felt they have successfully performed the gesture, but the system did not recognize it. The blue grid shows the opposite. We can see from the heat map, only 74% of trails in Group A matched the model output, while the match rate in Group B reached 95%. Among all mismatch in Group A, 87% were overestimation. That means participants with motor impairment believe they had successfully completed the gestures, but the system did not recognize it. After identifying the perception gap, we further analyzed the movement trajectories of the gesture related to. Our results show that gestures with a high perception gap are not random. Instead, they follow some classical football patterns. We then classified this difference between users' intent gesture and their actual movement trajectories. The first type is aptitude. The gesture is correct, but the movement is too small for the model to recognize. The second type is direction. For example, the gesture may move in one direction, but the system expects another. The third type is temporary dynamics. The gesture may begin too slow or be performed with unstable timing. The fourth type is the activation region. Users may rely on different muscle regions to complete the gesture. We also provide several examples you can find in our paper. Trajectories analysis help us understand why the model can't work, and the participant feedback help us understand the user's feeling. Only by combining these two perspectives can we fully explain the reason of perception gap. So we further analyze the feedback from the participant while they are performing these gestures. From the interview, we found several recurrent types of the experience. The first was reduced movement awareness. Some participants spent more time to ensure where their face had moved. The second was spatial disorientation, especially confused in distinguish left from right. The third was a motor coordination difficulty, where participants found it hard to precisely control small, isolated muscle movement. And finally, in the discussion part, we also found in diversity in gesture interpretation. That means participants often had their own understanding of what a gesture should named. In the discussion part, we propose recognition failures are not just a classification error, but a sensory motor alignment problem between user motor abilities and their model's assumptions. These mismatches are not only technique error, they can also produce real access barriers, which we describe as ability-sensitive allocative harm. Finally, we offered some potential solutions to solve these problems, and more detail can be found in our paper. Thank you for your time.
Thank you for the presentation, Siu. So we actually have maybe time for one question. Okay. Oh, yeah. I think there's one right there.
Thank you, Siri, for your fascinating presentation. So your paper introduces perception gap. Why is this more meaningful than simply reporting recognition accuracy? Isn't it just another way of describing the model failure?
I think accuracy only tells us whether the model was right or wrong. However, perception gaps tell us whether the user and the system agreeing on the successful completions. In our study, many participants feel they had successfully performed a gesture, but the system still failed to recognize it. That's important because from the user's perspective, the issue is that they have performed these gestures, but they was rejected by the systems. So I think combined with the result from the analysis of perception gap, we can have a deep understanding with why this system can't work. We can have a view from the participants, and in the future that might be is a good way to design more accessible interface.
Thank you.
Great, thank you for the question, and let's thank the speaker again for the presentation.
Thank you.
Okay, next we have two presenters. So first we have Singh Hu from City University of Hong Kong / the University of Queensland. And then second speaker is Zhenhao Zhang from Southern University of Science and Technology. And they'll be presenting their paper on living with data, exploring physicalization approaches to sedentary behavior intervention for older adults in everyday life.
Okay, fine. Thank you so much. Hello, everyone. Thank you for being here. My name is Singh from University of Hong Kong. The University of Queensland and postdoc in Hong Kong, City University of Hong Kong. And today, my collaborator Junhan and I am excited to present our work, Living with Data, exploring physicalization approach to sedentary behavior intervention for old adults in everyday life.
Okay, so before we begin, I'd like to let you to think about how many of you check your health using a smartwatch or phone app. Most of us are surrounded by health data on screen every day, step counts, heart rate, sitting time, etc. But have you ever feel overwhelmed or even anxious looking at those numbers? Today, we will show you a different way of engaging with health data. One that doesn't rely on screens at all. Current health and wellness technologies primarily rely on screen-based notifications, dashboards, charts, and button alerts. These tools emphasize numerical precision and are designed for individual self-optimization. However, for older adults, such as tools can feel clinical, cognitively demanding, and anxiety-inducing. Research also shows that engagement with these tools frequently declines over time. This is especially concerning because sedentary behavior is a crucial health risk for older adults.
Through our research, we found that old adults have very different needs and requirements for the younger user one. They don't want the complex applications with small text, loading notifications, or clinic dashboards that remind them of the hospital. What they want is simple, comfortable, and emotional easy. They want a device that blend into their home routines and respect their autonomy and dignity. This creates a clear gap. How can we represent sedentary data in ambient, physical forms that old adults can actually live with?
So our approach is data physicalization. Instead of displaying number of thin screens, we transform abstract sedentary data into tangible aesthetic forms embodied in everyday domestic objects.
We posed two research questions. First, how can the abstract sedentary data be translated into the physical forms from that accessible to old adults? And second, how can ambient data physicalization different from the traditional screen-based notification digital reminders? To answer these questions, we proposed research through the design methodologies across three phases. The first one involved the ethnographical observation of 15 older people in the nursing home, followed by the same structure interview with 12 of them. In the second was the poster demo discussions with 9 stakeholders, such as general researchers, interaction designers, and older people themselves. In the third one was the prototype development, where we placed our systems in 5 older people's home for the full days, followed by interviews. In the phase 1, we spent time observing the older people's daily routines, sitting behaviors, and their interactions with the everyday objects and the technicals. We also introduced the early design concepts and props, including such as the smartphone application concept. And what we found was really interesting. Many participant activities resist using the smartphones. One of our participants said, if I can choose, I don't want to use the smartphones. It has too many functions because it's really hard to control it. But we also noticed that the cushion repeatedly appeared as a modern but central object in their sitting rooms. This led us a keen insight. Cushion could be a promising low-boundary sensing surface. As our participant 1 told during the observation, the cushion is something I always use when I sit there. Embodying sensing into the cushion promised minimal changes to their physical environment. The technical would be invisible and the experience unchanged.
So building on this insights, in phase 2, we refined the concept into a 2-part system, a sensor cushion plus an external display object. Initially, we hypothesized that numeric or bar chart validations could be support clear self-monitoring. So we presented this concept to our 9 stakeholders through poster demo discussions, but the reaction was strongly negative. Participants described the chart as corny, boring, and annoying. P15 said it reminded me of how I felt when I needed to go to the hospital, and P13 said she felt oppressed by the explicit numeric feedback. And these 3 actions made the design direction crystal clear. Explicit data cause anxiety. We need to shift from clinical quantitative displays towards something ambient, non-numeric, and furniture-like. This was the turning point that shaped the final system called Kushilumi. And let me introduce the Kushilumi system. It has 2 physical artifacts. The sensing cushion is a regular-looking foam cushion embedded with 2 flexible sensors and a microcontroller. It detects when someone sits or stands together with the ambient light with the mute button, which could show different state of sitting time. And the technology is completely invisible for older adults. And here's how the light behaves with the sitting time lasting.
In the phase 3, we developed 5 systems in 5 older adults' homes for 1 full day each. The cushion was placed in their most frequently used chair, and the lamp set on the nearby table. Participants went about their daily naturally. The result was encouraging and interesting. We've observed 12 of them standing events totally, and in 8 of these 12, the participants' first activities after standing actually matched one of the icons on our lamp. And we also note 11 instances of the participants smiling when they noticed the light, and 0 instances of the frowning or verbal resistance. Now, for our findings for research question 1, we found the systems may be effectively mitigate the data accessibility through what we call the atmosphere abstractions. One participant had particular strong feelings. She compared her previously wearable experience, as Kurt said, ticking desk countdown strummed to my waist. Every vibration scrumming, I'd felt again. It in constrict. She described the cushion looming by saying, "The doesn't count me down to ground. It is feels bright, and it's just a fact, like the counterpoint, no Wobbrock." The King was refining the data as a natural environment, singular rather than a personal performance metric. Beyond the reducing the accessibility, participants developed a sense of the companionship with the systems. Our participant Nice described it as a beautifully sense. It's not a data, it's like an atmosphere, like when the sun sets and the room gets warm and the garden. It just changed the feeling of the room. It's very poetic way of the knowing time has passed. Another code is gently no clinic and like a pet in her table. 2 participants even agreed the light verbally. It tells us the data accessibility isn't just a simplification, it's about embedding people's personal meaning making.
For research question 2, we found that the Kushilumi differ fundamentally from traditional reminders by acting as a nudge rather than a dunk. Participants describe a mimetic, almost unconscious response to the lamp's visual cues. P4 said, "I saw the little man stretching, so I did the same. I feel natural." P11, who loved gardening, said the green light through the flower pattern turned the core getting up into a happy thought. And critically, PA contrasted with traditional alerts. My daughter's phone calls are an interruption. This light is a suggestion. It waits for a natural break. It's flat. The mute pattern turned out to be surprisingly important. P14 told us the first thing I did was to touch the top to see if I could turn it off. I could. That was the most important part because I knew I was in charge.
These findings let us know to the concept of the living with data. The traditional model treats health data as external metrics, requiring active interaction, comment, and compliance. Our approach proposes a different relationship, mapping the data as ambient qualities, suggestions, and negotiation, coordinating, and companionship. This is different from the ticking, death, countdown, and the sunset in the room. Personal health information becomes woven into the fabric of our daily lives, not standing apart of just an object of the screening.
So we distill 3 design implications from our research. First, decouple sensing from display. For sanitary data continuously into physical model in the home's background. Second, we subtle modularizations of light and metaphors rather than explicit numbers. And third, design quite negotiate form of engagement that preserve autonomy and dignity.
Of course, we acknowledge several limitations as in the slides shows.
So to conclude, our cultural learning system demonstrates that creating data physicalizations for older adults requires a shift from merely informing users to enable them to live with and through their data.
Thank you for your attention. We are happy to talk with you guys, take questions and collaborations. You can also reach our emails, and our contact information is on the screen. Thanks. Have a nice day, everyone.
Great, thank you for the presentation. Again, unfortunately, due to time, we won't have time for questions. But that will be wrapping up our session of navigating biases in accessibility and aging. Again, I know we had limited time or no time for Q&A, so I encourage you to come up and talk to the authors directly now. But I do ask you to talk to them outside of this room because we will need to clear out this space for the next event of Sekai Town Hall. Again, I want to thank all the presenters for their presentation, so let's give another round of applause.